P1 to P6, and their arrival times are this. Okay, and their burst times 7, 5, 3, 1, 2, 1. Okay, so for the sixth list of processes, we have to find out waiting time, completion time, and then turnaround time. Okay, so before I switch to this problem solving, first I would like to tell you what is SRTF. SRTF stands for shortest remaining time first, right? So as I discussed before, there are two schemes or two approaches or two modes, isn't it? They are preemptive and non-preemptive. What does mean by preemptive? A preemptive approach is nothing but a scheduler is switched to the preemptive approach only if the process is currently in executable mode. It means current process is allocated to CPU, but due to some emergency or high priority, the current executing process is forcefully released from the CPU. As it released, the CPU will switch to the next urgent or prioritized process. It means that the current executing process, whichever is preempted, that will get back to the ready queue as the remaining time is still there, right? So whenever the CPU switch back to that process, again it will start only from that point wherever it is preempted, right? So please do remember this algorithm is a subpart of SJF algorithm, that is shortest job first. Okay, so sometimes in the questions you may be asked by giving the list of processes, arrival times and the burst times, and ask you to find out the waiting time, turnaround time, their totals and their averages. Okay, so if this is the case, you have to solve by using non-preemption approach. Is that clear? Now, otherwise, if the question asks you to solve it with preemptive approach, then you have to follow the second approach. Is that clear? Or else, sometimes the question will be mentioned with this word, this abbreviated word, that is SRTF. It means by default you have to understand that for the given problem you have to solve it by applying preemptive approach. Okay, this is very, very important. Please listen carefully. If you can understand this problem, then it is easy for you to understand the remaining algorithms as well. Okay, now let's start. So as we learned that we can find out or calculate individual processes waiting times, completion time, turnaround time only by the Gantt chart. Okay, so here's the bottom. I'm going to calculate the Gantt chart. Sorry, construct the Gantt chart. Right now, also I will maintain a queue over here. Okay, कुछ तो भी problem हो रहा बोले तो you please prompt me. You just switch on your mic and tell me. Okay, no problem. Fine. Now here, as you look at the table, if you observe carefully, which process is available in the ready queue? Available in the sense ready for an execution.
P1. P1.
Why you are saying confidently that only the P1 process? By looking at the arrival time. Okay. Now in the ready queue, one process got settled or set in a ready queue, which is eagerly waiting for an execution, that is process 1. As it is arrived first, then it is very clear picture that CPU isn't busy with any other process, right? So a 0 itself indicates that before P1 there is no process which is allocated to CPU. It means CPU is completely free. Clear? Now what does the scheduler do? Scheduler invoke and it pick only the available process, that is P1. So as P1 is waited for 0th instance of time, right? As it arrived, it went into execution because CPU is free or CPU is available. Now the process burst time is what? 7. Isn't it? Listen carefully. The process is expected to complete its amount of work within a 7 milliseconds of time, right? Now, As it is purely preemption approach, the process has to be preempted by two conditions. What is the first condition? First condition is, are there any new processes arrived or not? Clear? If that condition satisfied, then the scheduler will look into second condition. What is the second condition? Is new arrived process burst time is lesser than current executing process or not? I repeat, the current executing process can be preempted by two conditions, by satisfying two conditions. What is the first condition? Are there any new processes available or not? If new process is available, if the first condition satisfies, then it will move on to the second condition. Okay, so the second condition itself decides that whether the current executing process can be preempted or not. Clear? Now, what is the second condition? If new processes are available or arrived at their respective times, is new arrived process burst times are lesser than currently executing process burst times or not? Let's do it. Now, P1 process has been picked or selected or allocated to CPU by the scheduler, right? Now, what happens is, here every time whichever process is being taken, that will be resumed for 1 unit of time, and it will look into the queue and checks is new process arrived or not. Okay, now by this time, can you please observe by looking at the table, is there any new process arrived by this instance of time?
P2 after 1 second.
Yes, after 1 millisecond, one new process has been arrived, that is P2. Now, can I say P2 arrived means, yes, it is also eagerly waiting for an execution, right? Now, see here, by this instance of time, P2 is available. Now, whether the P1 to be preempted or not, the scheduler will decide depending upon the second condition. So, what is the second condition? Is P2 new arrived process, P2 process is burst time is lesser than currently executing process burst time or not? Okay, yes or no? Now, to avoid one more confusion, how much time does P1 has completed? How much amount of work is P1 completed?
1 unit of
1 unit of work, right? Now, what is the remaining time?
6.
Very good. Okay, now you will be checking the second condition by the updated values only. Okay, so kiska kam hai? Which process's burst time is lesser? P2 or P1?
P2.
P2. Now what happens? P1 process is preempted. Okay, P1 process is preempted. Now CPU will take P2 process. Why? I've already told you the two reasons. By this instance of time, new process arrived, as P2 process burst time is lesser than P1 process. Okay. Now, P1 will be updated with the the remaining burst time. Okay. Now, when P2 is picked, P2 is also resumed for 1 unit of time. Okay. Now, put together, what is the CPU time?
2 units.
2 units. Okay, so does it mean that P2 burst time should be updated? Yes.
Yes.
Isn't it? So what is the value, current value now?
4.
4. Okay, now by this unit of time, can you tell me, are there any new processes arrived?
P3.
Yes,
P3.
yes. P3 has been arrived, isn't it? Now, if P3 process is arrived, now what is the second condition to be checked?
Burst time less than.
Burst time is lesser than the currently executing process or not. Okay. Is second condition satisfied?
Yes, ma'am.
Yes, ma'am.
So if second condition is satisfied, what should be done? P2 process should be preempted from the
Preempted.
CPU, and CPU should take P3
P3
process.
P-
Right? Okay. So I'm sorry, I forgot to write over here. right? Now as P3 is available, now CPU is taking P3 process by satisfying or fulfilling the two conditions. Okay. Now coming to the P3 process. P3 process is also run that instance of time and ratio for 1 unit of time to check why it has been doing checking for every 1 unit of completion, because scheduler need to fulfill the purpose of SRTF. Whichever the processes arrive with a shorter burst time, if that process executes first, then the throughput can be improved. CPU utilization can also be increased. Okay, if we are not doing so, then definitely we are degrading the performance. Okay, so to overcome that, every process is preempted for 1 unit of time. Okay, now put together, what is the total CPU time?
3.
Huh?
3.
3. Okay, now what is the remaining time of P3 process?
2.
2. Very good. Now by this time, are there any new processes arrived?
P4.
P4.
Yes, P4 is available. Okay, now P4 is available. Now you only tell me CPU should take which process? Should it remain with the P3 process or should it switch to new process?
P4, ma'am.
Why P4?
Because P4 is less.
Because the burst time is lesser than the currently executing process. Now P3 is preempted. CPU has taken P4 process. Clear? Now, even see, as I told you that just look for the shorter burst time process in order to improvise the throughput as well as the CPU utilization. For that case, P4 is also preempted for or resumed for 1 unit of work. Now, what is the total CPU time?
4 units.
4. Okay. Now, is there any remaining left
No,
for
ma'am.
P4 process? No. Okay. So that case, to avoid the confusion, you please render it as 0. It means P4 is the first process which has successfully completed its work, isn't it? So does can I say our objective is fulfilled? What is that objective? The purpose of these algorithm is to accomplish or execute the shorter burst times processes first, isn't it? Now P4 is the first process which is successfully executed completely, isn't it? Now by this time, are there any new processes arrived?
P5.
P5.
P5 has arrived and it is available and it's waiting for an execution. Now if you look at the burst times, P5 burst time is 2. Now the question comes, will scheduler picks P5 process with 2 burst time, or will it also check back with the existing processes burst time? Yes, the scheduler will also check with the existing processes burst times. Okay, so okay, till here now. So till now there were 3 processes went under execution, completed some unit of work and waiting for the execution with the remaining time, right? Now if it look back or compares the second condition, the scheduler found that there is one more process with equal burst time, that is P3 and P5, right? P3, P5 burst times are same, 2, 2. If this is the case, the question comes to, or the scheduler should make a proper decision which process to be allocated to CPU now. Okay, to avoid this confusion, what we generally do is, as per the author statement, if this situation arises, if the process or scheduler encounter with this kind of situations, then simply follow this order. Now can someone tell me, if it follows FCF's order, which process should be allocated to CPU now?
P3.
Very good, P3 process. Now again P3 got a chance, right? Now what is the P3 process remaining time? 2, isn't it? Now, as per the procedure of SRTF, P3 also should resume for 1 unit of work to check whether the new processes are arrived in this instance of time and its burst time or smaller to take under execution or not. Now, what is the total CPU time? 5.
5, ma'am.
What is the remaining time of P3 process?
1.
1.
1.
1. Okay. Now, by this instance of time, are there any new processes arrived?
P6.
P6 arrived. Okay. Now, P6 process is available. Clear. Now, the same situation arises. Okay. Prashant.
మేడం
Prashant, ఇక్కడ రెండు processes ఉన్నాయి కదా, P3 and P6 with same burst times, equal burst time. 1 and 1. Now, CPU scheduler will has to choose one process among them, right? మరి ఇప్పుడు scheduler ఏ ప్రాసెస్ ని చూస్ చేసుకుంటుంది? P3 ఆ P6 ఆ? డిలే చేయొద్దు, వాట్సాప్లలో ఆన్సర్లు షేర్ చేసుకుంటూ. పిక్ P3 ఆ P6 ఆ? ఎందుకు P6?
అంటే వేరే దానికి వెళ్ళాలి న్యూ వన్.
ఇందాక నేను చెప్పింది వినలే. మన రవిచంద్ర ఆన్సర్ ఇస్తాడు చూడు. రవిచంద్ర, Ravi, your mic
Yes,
is
ma'am.
on.
Yes,
Just
ma'am.
tell me simple question, simple answer. P3, P6. Okay, two processes are there, and their burst times are 1 and 1. Same burst times. ఇప్పుడు scheduler అనే ప్రోగ్రామ్ P3 ప్రాసెస్ ని CPU కి allocate చేస్తుందా, P6 ప్రాసెస్ ని CPU కి allocate చేస్తుందా? వాట్సాప్ చెక్ చేయకు. రవి,
P6 కి చేస్తాను మ్యామ్.
ఎందుకట్లా?
సారీ P3 కి చేస్తాను మ్యామ్.
ఎందుకట్లా?
FCFS మ్యామ్, ఫస్ట్ కమ్ ఫస్ట్ సర్వ్.
ఎందుకు P6 ఎందుకు తీసుకోకూడదు? P6 అరైవ్ అయింది కదా ఇప్పుడు.
P3 ముందు వస్తారు కదా మ్యామ్.
P3 ముందు వచ్చింది కాబట్టి P3కి వెళ్తుందా? అంతేనా?
అంతే మ్యామ్.
నీకు ఆన్సర్ చెప్పిన వాడికి దండం. ఓకే, అరుణ. అరుణ, C8. You should respond me very quick. అచ్చా, సాదియా.
Yes, ma'am.
అరుణ, ఇప్పుడు రవి గారు చెప్పింది కరెక్టా?
Not sure, ma'am.
Not sure. Sadia, it's your turn. Sadia.
Yes, ma'am.
Please tell me, scheduler picks which process, either P3 or a P6?
P6, ma'am.
Shreya 94. Shreya 94.
Yes, ma'am.
Please tell me, dear, the simple answer. Scheduler is going to pick a P3 process or a P6 process, as the burst times are same. Okay, Sushant.
I don't know, ma'am.
Okay, Sushant.
యా ఎస్ మ్యామ్.
ఇప్పుడు చెప్పండి,
P3 మ్యామ్.
ఎందుకు P3?
మ్యామ్ క్యూలో అదే ఫస్ట్ ఉంది మ్యామ్. ఫస్ట్ కమ్ ఫస్ట్ సర్వ్ P3 కి వస్తుంది P6 కంటే.
Okay. See guys, please listen carefully. If you stuck at any point, if you don't understand such cases, such situations, then it is very difficult for you to do all calculations. Please, my humble request. Done. Thank you, Sushant. I hope others would have understood what Sushant was saying. As I said before, the same situation arose with the previous processes as well. That is P3, I mean between P3 and P5. Now the same situation is encountered with P4 and P6 processes. Sorry, P3 and P6 processes. As by this time P6 process arrived and its burst time is 1, and there's one more process which was went under execution and left with the remaining time, that is P3 process with 1 burst time. Now the scheduler has to make a proper decision which process should be taken, either P3 or a P6. Okay, why not P6? Because if the two processes are having the same burst times, then simply you follow FCFS order. Okay, FCFS order. Clear? So this is the only justification what you can make the processes with same burst times. Okay, so if you choose another process, then definitely you will be doing a big mistake, with which also waiting time, completion time, turnaround, everything gets affected. Okay, the only reason is this: follow simply FCFS order. Now the CPU is continuing with the P3 process only, just by following FCFS order. Now what is the remaining time of P3 process?
Zero, ma'am.
Yeah, ma'am.
It was 1. Now as soon as it went under execution, as CPU spent upon all the processes by 6 milliseconds, now P3 is also completed. So P3 has been removed from the queue. It means went to terminate state. Done. Now, as of now, if you look at this queue, which processes are available and waiting for an execution? P1, P2, P5 and P6. Okay, and what are the burst times? 6, 4, 2, 1. Clear. Now by this instance of time, even if you look back to the table, you will easily make out that there are no new processes arrived in this time. Clear. If no new processes arrive, just by applying shortest SJF procedure and allocate process by process to the CPU for successful execution. Right? The remaining processes are P1, P2 and P5, P6. Now, among these processes, scheduler select which process? Huh? P? P6. Okay. Now, should P6 resume for 1 millisecond, or should it continue? Even if it resume or continue, it doesn't make any difference, as the burst time is only 1. Clear? Now with this amount of work, P6 has successfully completed its task, wherein the CPU time is increased to 7. Clear? Now the available processes are P1, P2 and P5. Now among these 3 processes, which process is selected by scheduler? Will answer by Famshi. Famshi. A2. Shravanti 73. Shravanti 73. Okay. So the remaining processes available with remaining burst times are P2, P1 and P5. Right? And if the decision comes to the scheduler to make which process should be pegged and allocated to CPU, then it simply follow SJF process. Right? So among the 3 processes, which process is holding with less burst time? That is P5. Right? Now P5 is taken for an execution, and even if prompt or resumed for 1 unit of work, it doesn't make any difference, as there are no new processes arriving or arrived by this instance of time. Right? So simply what does it do? As no new processes arrived, it simply CPU is not going to leave this processes until it completes its amount of work, right? So what is the total CPU time? 7 plus 2, right? So successfully P5 also completed, and the left two processes are P1 and P2, right? Now the scheduler is gonna choose the process with less remaining time, right? That is P2 process. P2 process remaining time is 4. Now put together total CPU time is 9 plus 4, 13. So no remaining time of P2 process. P2 is completed. As there is one process with higher burst time, that is P1 process with 6 remaining time. Now the time comes to P1 process to go under execution, right? So 13 plus 6,
19.
19. So total all the processes were executed, right? Now this algorithm is fulfill the objective, right? The higher burst times has to execute last. If the higher burst time processes executes first, there will be a delay, or the lowest burst time processes are waiting for a longer period until higher burst time processes gets executed successfully. So that difficulty or that problem is overcome in the SRTF algorithm. Clear? Now the time comes to calculate waiting time, isn't it? Now let us find out the waiting times of individual processes. As it is purely preemptive, observe the screen very carefully. As it is preemption approach, there are many processes which have preempted in between and occurred more than once, isn't it? If you look at the process 1, let's look at the Gantt chart and tell me how many times does P1 occur?
2 times.
One time.
2 times, right? Now, while calculating P1 process waiting time, so simply look at here. First, take the value of the last occurred waiting time, that is 13. Okay, 13 minus, if at all this process has occurred before, directly switch to that position, that is this, right? Now you even also have to deduct this amount of work. Why? Because the addition of this only we have been reached to 13 value, right? So why should I consider this time, isn't it? So this interval of time should also be deducted when you calculate waiting time. So what is the time interval of this? 1, right? And minus its waiting time, arrival time. What is that? 0. So together, what is the total waiting time? 12. P1 process? 12. Okay? Jagrataga vinandi, confuse avagudadu. Next process. Now the turn comes to P2 process. How many times does P2 occur?
2 times.
2 times. Okay? The same case is reflected for P2 process as well. First, take the last occurred P2 process waiting time. Okay, how much time does it exactly wait to complete it full work? That is 9. 9 minus previous occurred time interval. Where is that? Here, right? Now what is the time interval here? 1 minus 2. 1, right? So is there any other, the same process occurred for third time? No, right? So now deduct the arrival time minus 1 is equal to how much? Am I correct?
Yes, ma'am.
Okay. Now P2 is completed. Now coming back to a P3 process. How many times does P3 occur?
3 times, ma'am.
Twice. Now what you're supposed to do? Take the last occurred waiting time. That is how much?
6.
5 minus
4 minus 2.
Yeah, 4 minus 2 in the sense this interval 1 minus this interval. Okay, ఇప్పుడు -2 అని రాసాను అనుకో, అది ఏంటి అనేది మళ్ళీ ఒక డౌట్ వస్తుంది, రైట్? సో just to overcome that, simply I am deducting twice as it is occurred thrice, right? This interval and this interval minus its arrival time, that is 2.
2.
So what is the total?
1.
5 minus 1 minus 1 minus 2.
1.
1 only na ma'am.
1 only. Okay. Next, P4 process. How many times does P4 occur?
Only once.
Only once. And what is its waiting time? This.
3.
3. So as this process hasn't occurred twice or more than once, so simply we are taking the last occurred or the only occurred waiting time and then deducting from the arrival time. 3 minus 3 is equal to
0.
0. So I told you, no, there should be one process with waiting time should be 0. What does it mean? This was the first process, right, which was successfully completed first, isn't it? Notice?
Yes ma'am. Yes
Right.
ma'am.
Now going to P5 process. P5. How many times it occurred?
1 time.
Only one time.
1 time.
The last occurred or once occurred waiting time minus its arrival time. 7 minus 4 equal to 3. Right? Now coming to the P6 process. P6 is also occurred only once. Simply take that waiting time, that is 6, minus its arrival time, that is 5, equal to 1. Clear? Now these are the weightings among all the processes. Now coming to the completion time. Completion time, you will be taking the last occurred right side value. Okay, let's see what are they. I'll quickly close this. P1 process, as it is occurred twice, so we are going to consider at what time, exactly at what instance of time the process is successfully terminated, that is 90. Okay, I'm writing the completion time values here, 90. Next, P2 process.
13.
Very good, 13. P3 process.
6 ma'am.
6. P4 process.
4.
4. P5 process.
9 ma'am.
9. P6 process.
7.
7. Okay, so these are the completion times. Now coming to the turnaround time. What is the calculation for turnaround time? CT minus 80.
Minus 80.
19 minus 0. Oh, sorry. Yeah, 19 minus 0. 19. 13 minus 1. This and this. This and this. This and this. This and this.
5.
This and this. Oh, clear, no? Now I think it is easy for you to find out the total waiting times, total turnaround times. Clear?
Yes,
Okay. Those are having doubts, they can ask me questions. So meanwhile, I'll take attendance. B4, Swinish.
Yes, ma'am. Present, ma'am.
Bhuvana, B7.
Present, ma'am.
86, Honey.
Yes, ma'am.
89, Shivaram.
Yes, ma'am.
A5, Srujan.
Present, ma'am.
74, Akshara.